Greetings to all. Thank you for joining us, ETIHAD Airways. Today, I would like to share with you some advice and facts about aviation today. The first topic that I would like to present you is the ice. The icing is the process of removing snow, ice or frost from a surface. Anti-icing is the application of chemicals that not only the ice but also remain on the surface and continue to delay the reformation of ice for a certain period of time, or prevent adhesion of ice to removal easier. For small aircraft, it using manual de-icing through mechanical movements like pushing or scrubbing. Because they don't use chemical fluid to clear the ice and it can save the cost. When during flight, anti-icing fluids are ineffective, so aircraft are equipped with in-flight systems that prevent ice build-up during operation. Nowadays, the new hybrid de-icing technology by Invicon Company and NEI Corporation currently in the works to improve ice build-up prevention. This technology tests at NASA's icing research tunnel, utilizes an anti-ice coating by NEI that creates a lubricating surface that can reduce the adhesion effectiveness of ice by up 80%. This anti-ice coating can be retrofitted onto existing aircraft through sparing and paint a bright feature for anti-ice measurements.
The second topic, turbulence. Turbulence is the shaking caused by a break in the airflow that enables a plane to fly. Turbulence, also referred to as air pockets, can momentarily cause a sudden loss of altitude. How long does a turbulence last? It might be short or long depending on the condition of the irregular airflow or air pocket. What causes airplane turbulence? The first one, thermals. A plumpy ride can result when the sun heat causes thermals, a pocket of hot air to rise and interact with the current winds while in flight. Turbulence is produced when thermals block the usual wind currents that must travel away from them. The second, wake turbulence from other aircraft. When an airplane or helicopter passes by another one and is catch in the latter's wake. This is known as wake turbulence. Smaller planes are more vulnerable if they collide with a larger jet, since bigger planes leave bigger wakes. For this reason, there are rules defining the bare minimum space between two aircraft. The third one, wind at lower altitudes. Closer to the ground, the wind is subject to friction and its flow is affected by the Earth's surface and everything on it. The wind is not as strange and steady on the ground. Variation in direction and speed can cause turbulence at low levels. And the fourth one, mountains. Air can steer upwards when it encounters tall mountains, causing airplane turbulence.
That topic is holding. Holding patterns are a way for air traffic control to delay an aircraft from proceeding on course. Standard holding pattern. A standard holding pattern is depicted in the following diagram, which shows the group track as it would appear in still air conditions. The holding fig can be any of our RNDB, radian DME fig, a specified waypoint, or in some circumstances the current aircraft position as generated by the flight management system. Non-standard holding pattern. A non-standard holding pattern is one in which the turns are made to the left or the inbound timing is other than standard values, unless the ATC clearance include instruction to hold non-standard. Entry procedures. Sector 1. Procedures Parallel entry. Upon reaching the fixed, turn onto the outbound heading of the holding pattern for the appropriate period of time. Turn left to intercept the inbound track or to return directly to the fixed. On the second arrival over the fixed, turn right and follow the holding pattern. Sector 2. Procedures Offset entry. Upon reaching the fixed, turn to heading the resolve in a track having an angle of 30 degrees or less from the inbound track, reciprocal on the holding side. Continue for the appropriate period of time, then turn right to intercept the inbound track and follow in the holding pattern. Sector 3. Procedures Direct entry. Upon reaching the fixed, turn right and follow the holding pattern. DME procedures. DME holding is subject to the same entry and holding procedures as a standard holding pattern except the stances in nautical miles. In describing the direction from the fixed on which to hold and the limits of ADME holding patterns, an ATC clearance will specify the DME distance from the navigation aid at which the inbound and outbound legs are to be terminated. It is speed limitation.
The fourth topic, wind shear. Wind shear is defined as a y direction and speed change over vertical or horizontal distance. It is significant when it causes to an aircraft headwind or headwind or tailwind, such that the aircraft is doubly displaced from its intended flight path and substantial control action is required to correct. The last topic, cockpit flight deck. The cockpit is the section where the pilot and the co-pilot manage the aircraft. The two main functions of the cockpit are to provide the pilot with a good answer and to make all control mechanisms accessible to them. Planes are also designed based on the same principle of any vehicle. Cockpit voice recorder. The CVR records the flight clear's voice as well as other sound inside the cockpit. The recorder cockpit area microphone is usually located on the overhead instrument panel between the two pilots. Specifications: cockpit flight recorder time recorded 30 minutes, continuous 2 hours for solid-state digital units. Number of channels is 4. Fire resistance 1100 degrees Celsius in 30 minutes. Water pressure resistance submerged 20,000 foot. Underwater locator beacon 37.5 kHz. Battery has shelf life of 6 years or more with 30-day operation capability upon activation. I hope you can get useful knowledge from this presentation. Thank you.